I can go? All right. Thank you, everyone. For those of you who don't know me, there's probably not many of you now. My name's Stu Fox. I work for Microsoft here in New Zealand. I'm a technical specialist in the data center business. I cover System Center and Windows Server, including Hyper-V. How many of you came to my Hyper-V overview session yesterday? Most of you, cool. And you came back, that's good news. Thank you. And how many of you have just been to Ben's storage session? Okay, cool. I might be as good as him, sorry. So I'm going to talk to you about Hyper-V networking, and I've got quite a bit to cover, so there probably won't be time for questions. So the same thing applies to the overview session. Grab me in the hub tomorrow or something. I'll be around. So, if you need to know anything else, grab me. There you go. So listen, I won't bother with objectives. So what we're going to talk about, we have no objectives. We're just going to ramble. So what we're going to talk about is Hyper-V networking and some of the things that we've been thinking about. And some of the things we've been talking to our customers about. And the first thing is, and I don't know if you picked this up yesterday in the overview session, or you've picked it up in some of the other sessions around Hyper-V and Windows Server 2012. There's a lot of focus on multi-tenancy. A huge focus, and it's one of the things that that we've really tried to make easy to multi-tenant Windows Server 2012, and Hyper-V is no exception to that. So there's a bunch of things that we've done to make sure that we can do that, and that covers off a whole bunch of the networking functionality. So for our customers, if we have failures in our data centers, we want continuous availability. It's one of the words you probably will have heard a bit over the last few days, continuous availability in Windows Server 2012. Not high availability, but continuous availability. So customers want reliability in their data center. They want security. So in a multi-tenant environment, I want to know that when I'm running on shared infrastructure, that my machines can't be compromised by another tenant on that same environment. They want predictability, right? So when I am running on that shared infrastructure and I've got a bunch of workloads running, all competing for that same network bandwidth, I want some predictability around that. And that might be, hey, I want to ensure that I've got some specific capacity, or I want to make sure that I'm not able to exceed specific capacity. So they want some predictability around that for bandwidth. And they also want scalability. So, as a hoster, the more workloads that a hoster can run on the platform, the better economics, and that's good for customers too, because the more workloads a host is running, the less they charge you for them. So, so we want scalability, and customers want high performance as well. Of course, everything should perform exceptionally. And the other thing that's really interesting is that in terms of extensibility, there's a lot of ask around, hey, we want options around how we extend what we do in the virtualizations, in the network virtualizations, but in the networking space. So there's a bunch of stuff we've done around that, and we'll look at all of those things. And so that's kind of the theme for this session. So there's those 6 things that we've just talked about real quickly. Windows Server 2012 is designed to meet all of those requirements. So, the basics, the Hyper-V switch. The Hyper-V switch is the thing that deals with network traffic between virtual machines, between the outside world, and in fact the host OS. So the Hyper-V virtual switch is the key to all of this. And so it sits there, it's the guy that's in between all that virtual network traffic, going between VMs, going between VMs out to the outside world, whatever. That's that virtual switch is sitting there doing that. And and we've come from a reasonably dumb virtual switch in Hyper-V 2008 R2, and we've got a lot more smarts built into the virtual switch now, and we'll go over all that stuff. So if you were in my overview session yesterday, you will have seen this slide. This is some of this new stuff that we deliver, and we're going to look at a few of these different bits and pieces. But basically everything here is new. This is all new stuff in Windows Server 2012. So let's have a look at we'll quickly look at reliability. I'm not going to spend a lot of time on this because it's been covered in Daniel's session. NIC teaming, it's built into the platform. Hyper-V can leverage it, and Daniel probably talked about, you can build a team up to 32 NICs, multiple vendors. Only guidance really is the same speed, and we can leverage those NIC teams in the Hyper-V virtual switch. So you can team underneath, connect the virtual switch up to a team, and run all your guest traffic through that NIC team. Should you lose a NIC, away you go. So like I said, I'm not going to labour the point on that one. But what we see is, is kind of a common Hyper-V config is, a teamed 10, from sort of now on, a teamed 10 gig eNIC. With actually all our traffic running over it, VM traffic, live migration traffic, storage traffic, management traffic, potentially, all those things, a converged fabric. And there's some stuff we've built into the operating system that will help us deal with that, and we'll look at that a little bit later. But that's kind of the reliability thing. We've got built in. We can deal with networking hardware failures, not a problem. We can. So let's just move on and talk about something else. But one of the great tweets I really liked from my session yesterday was something like, I no longer have to look at the hideous BACS interface. So if anyone's used the Broadcom teaming interface, NIC teaming, I don't have to look at the hideous Broadcom interface anymore, which I totally agree with. So let's have a look at some security stuff. So we've built a bunch of security stuff in to host multi-tenant workloads in a hybrid cloud. So so we're running maybe some workloads on premises, maybe some workloads in a public cloud or a hosted cloud. We've built some features in there as well. So first thing, real simple, port access control lists. So port access control lists we can set on a per VM basis. So we can do allows and denies on traffic going through. We can also do a counter, so you can actually measure VM network traffic using a counter, or what we call Hyper-V metering. So and they're actually implemented as port access control lists. We can specify MAC addresses, IP addresses, v4 or v6, we don't mind, or wildcard IP addresses. So we can actually set port ACLs. So if you want to do security just on, if you want to do port access control lists, you can do that pretty easily. And they're basically, like I say, the basic building blocks of virtual switch security. And like I said, counters or metering, so how do I measure what traffic's going through this thing, are actually also implemented as port ACLs. And the cool thing about the port ACLs is they're actually stored with the VM. So you can move your VM around, and those port ACLs actually follow the VM. They're not locked to the host, they're actually locked to the VM. So if you move a VM, the ACLs go with it. If you move a VM, the network metering goes with it as well, and actually all the history around the metering too. So you don't go like, move my machine from A to B, and the metering disappears and it starts from zero again. We move from A to B and we take the metering history with us. So it's pretty powerful. And we read counters with PowerShell or WMI. And so let's take a quick look at that, and it will be a pretty quick look. One of these guys. So, port ACLs. I've got a nice Team Foundation server here. I can go off and browse it and do all that kind of stuff. It'll run up quite nicely. What I can do is drop into PowerShell and set a deny rule on that. So that's basically, that may be a little bit hard to read, but so we're going to get VM, so we figure out the VM, add a network adapter ACL for the remote IP address 10.0.0.246, both directions, and action is deny. So do that, guess what happens? Pretty much a blank browser. My browser won't be able to get. So I've actually blocked the host from getting access to that guest. So no network access at all. It's just blocked by network ACL. And so so there you go. And so network ACLs are actually are all managed through PowerShell. You don't see them in the UI, and you don't see them in Virtual Machine Manager. Those kinds of things. You manage them through PowerShell. I think it's just a matter of time. The Hyper-V team didn't actually have time to build some of this stuff into the UI. But if you want to do ACLs, and basically I can remove that ACL, and I can refresh that page, and what do you know, back up again. So the port ACLs, pretty easy to configure. Just a PowerShell command, and that's on a per VM basis. And I can be pretty granular about that as well. So so that add VM network adapter ACL PowerShell commandlet. You can add IP addresses, you can add MAC addresses, you can add, do those kinds of things, and you can do it in a single direction or both directions. So that's port ACLs. Oh, I'm going to go through this again every time. Right, so one of the next things that we've done around security, IPsec task offload for VMs. So we think that IPsec will become more and more prevalent. In terms of workloads, we use it a lot internally at Microsoft. We think it will be much more important. It is pretty CPU intensive though, so there's a lot of work involved in encrypting and decrypting the packets as they go across the wire. So IPsec task offload lets us offload IPsec operations actually from a VM down to hardware that's able to deal with that offload. So we can actually, we're not just limited to the host operating system, but an offload task. We can actually also offload IPsec tasks from a VM as well, provided that hardware is present in the machine. And that basically is just something that's transparent and happens. You don't have to configure it. It's just there and just works. I think I said that a lot the other day too. It just works. So the next thing, Hyper-V network virtualization, and we touched on this briefly in the overview session yesterday. Hyper-V network virtualization is really taking the same concept we had around server virtualization. We can pick up a bunch of physical servers that are underutilized, run them on a single physical server, as our virtualization, and every server thinks it's running on, its own piece of tin and its own dedicated hardware. Same concept with network virtualizations. What we can do is we can pick up a network and run that virtual network on a physical network, and the virtual network actually thinks it's running as a physical network, and it doesn't really see the topology underneath your physical network. And there's a couple of things we're trying to solve here. One is that concept of, hey, I'm a customer, I want to bring my stuff into your environment, and the host is going, well, I want to keep security. I want to isolate you from tenant B. I also know that you've got an IP conflict with tenant B. I've got all these VLANs, but every time I make a change to my VLAN, some other switch down the line, I forget to do that switch, or the VLANs have to be configured everywhere, and I run out of VLANs. My switching infrastructure can't cope with it. My network guys get all annoyed every time I add a new VLAN, and it's just too hard to deal with, and everything's bad news. So with network virtualization, we get away from VLANs. And this is something that our hosts have really asked us for. They've said VLANs are just getting too hard to manage, especially at scale. So network virtualization allows us to do that. And what it gives us, so for a workload owner, someone who's moving their workload to the cloud, it gives us the ability to move their workload to the cloud and preserve their VM settings, so the IP addresses, those kinds of things. It allows us to preserve that stuff, and you can actually extend your data center out to a cloud-hosted environment. For an enterprise, I think of a couple of scenarios around the enterprise. I actually think of something that we don't have up here, something like dev test, right? So one of the things that people always do is in their dev test environment go, hey, I want to take a copy of the AD, and I want to take a copy of just about everything you've got, and I want to run that up in my dev environment. And you go, okay, and then you've got to isolate it and do all that stuff. But with Hyper-V network virtualization, you could basically pull that whole environment, run it as a virtual network on top of your Hyper-V environment, and be able to stand up multiple copies of your environment for devs to get access to. So there's some options there, but also things like and I've been through this a couple of times. That you've acquired a company, and you want to bring their infrastructure into your infrastructure, but hey, we actually end up using the same IP address. For some reason, we've ended up using the same IP address ranges, and so to bring them in, you actually have to bring them in and re-IP address them and change everything they do, and be a complete nightmare. So this is again, you could just bring in their stuff as a virtual network. And do that. Hosters, it allows you to offer bring your own IP, allows you to bring your own network topology, basically, and allows for scalable multi-tenancy. And for the data center admins, it allows you to basically place VMs without having to reconfigure the network every time or do that stuff. And it does bring the benefits of virtualization through into the network as well. So conceptually, a few concepts around how Hyper-V network virtualization works. Customer addresses. So here we've got two customers, blue and red. They've both got machines 10.0.0.5 and 10.0.0.7. Pretty straightforward. And we call those, they're called the customer addresses basically. So you'll hear me say CA or customer address. That's what we're referring to there. So each customer has their own unique addresses. And we've got our hosted environment, our data center environment with a couple of Hyper-V hosts. Let's call them host 1 and host 2, and we're able to run those two environments. And you see we've put those on a host. We've put the two machines 10.0.0.5 on the same host, the two machines 10.0.0.7 on the same host, and we're running a customer address space there. And then we've got what's called the provider address space. So basically, these are the physical addresses that sit on the Hyper-V hosts themselves. And so what the data center people would see actually physically on the network. So we've got a couple of different addresses there, and they are unique because they are running on a physical network fabric. So you do have these unique provider addresses. And so what we do, and we manage this through System Center. This is. Most of the other Hyper-V features, networking features, you can manage through the Hyper-V console or PowerShell. This feature should only be managed through System Center Virtual Machine Manager, and I'll show you the UI and stuff in a minute. But it is only managed through System Center. And what we do is we set up effectively a mapping table in System Center around our virtualization. So we say blue, when it's talking out on 10.0.0.5, is going to talk out and it's going to be effectively hidden behind 192.168.4.11, and same for red. So we end up with a mapping between customer address space and provider address space. And so we can run those. We have a copy of those mapping tables sitting on those hosts, and they know what to do with that traffic. So we'll delve into that a little bit further in a second. So a couple of other concepts. We've got a concept of what we call a customer network. And so a customer network is effectively a collection of subnets that form an isolation boundary. So that's your boundary of machines in that network can talk to one another. If you're outside of that network, you can't. And so you could end up having multiple customer networks, but you're likely to have at least, likely to have one. You could have multiples, but they are isolation boundaries. So each one of those, so machines in blue sales net can't see machines in blue R&D net. Machines in red HR net can't see any of the other two. But we also, inside those customer networks, we have virtual subnets, and they're basically broadcast boundaries. And think of those as your normal physical subnets. We have these virtual subnets, and every one of those subnets gets a virtual subnet ID. And that's important for the next slide. So basically, we have these customer networks, and each of those has a virtual subnet. And I'll show you this in the UI as well, so you can see what I'm talking about. And so the question was, does it do the layer 3 routing? And yeah, the network virtualization takes care of the layer 3 routing. And that's a good point to stop asking me questions about how that works, because as far as I can tell, it's kind of magic. So inside that blue R&D net, you see you've got 3 subnets in there. The network virtualization layer will take care of the layer 3 routing in there as well. So we use a protocol, GRE, which is a pretty common protocol for tunneling across virtual networks. And the good thing about GRE is that there's a whole bunch of network equipment out there that already understands GRE, and we don't have to rebuild, we don't have to go out and build a new ecosystem of hardware around GRE. We've made a couple of tweaks to the protocol, which we've submitted to the IETF to make it more network virtualization aware. And so it's this protocol NVGRE. And so what we do is we share the public address space between our VMs, but every bit of traffic that comes out from a isolated VM has the virtual subnet ID tagged to it as well. And so we'll have a look at that traffic flow now. So and this can actually work across different physical subnets as well. So you can actually have, in this case, you can see we've got our 10.0.0.5 machines sitting on 192.168.2.22, and our 10.0.0.7 addresses sitting on 192.168.5.55. So as long as there's routing between those subnets, we'll be able to talk between those two machines as though they were on the same physical network. And so what happens when we go to talk between these two machines, when we encapsulate the traffic. So, 10.0.0.5 on blue is sending to 10.0.0.7 on blue. We encapsulate that traffic with the MAC address and the virtual subnet ID. And the actual traffic that goes on the wire is a bit of traffic that goes from 192.168.2.22 to 192.168.5.55. And the only difference is that GRE key, or the virtual subnet ID. So that's unique for each virtual subnet. And then when it gets to the other side, it gets unwrapped. So network virtualization is transparent to the VMs. They don't know they're being virtualized. Only VM traffic's virtualized. Your management operating system traffic is not virtualized. And we'll talk about the Hyper-V switch and its extensions in a minute, in a little bit, but they operate in the customer address space, so you can still take advantage of all the Hyper-V network switch extensions. And then what happens is it goes through the stack and hits the network virtualization layer. And we'll have a quick look at what the traffic looks like. So when we go to send traffic, so say we're sending from blue 1 to blue 2, so first thing that happens is blue 1 does an ARP. So, pretty common. It'll do an ARP. Where's 10.0.0.7? Now, what would normally happen here is that would get flooded out across that particular broadcast domain, and 10.0.7 would reply. What happens in Hyper-V network virtualization, the Hyper-V switch will send that broadcast to any local VMs, so any VMs on that same host on that same virtual subnet ID. So it will go through the host, any machines are attached, it will send that broadcast. It'll also send it down to the network virtualization filter, but that's where it stops. It doesn't, ARP does not go out across to anywhere else in the network. It stops there. But what happens is the network virtualization filter goes and talks to System Center Virtual Machine Manager and grabs the mapping for where 10.0.0.7 is, and it fires it back into the network virtualization layer. So if it's not local, it goes off to Virtual Machine Manager to grab that. And so Virtual Machine Manager holds basically Hyper-V holds a subset of that mapping table to deal with the VMs that it has. Anything else it goes and grabs and sort of demand pages the remaining ARP addresses and IP addresses. So ARP doesn't go out to the network. It's important. So then the network virtualization layer sends up and says, hey, here's your MAC address, and here's your virtual and your virtual subnet ID, or it's tagged with the virtual subnet ID as it goes up. And then blue sends its bit of traffic. Hey, I'm sending from my MAC address to your MAC address, this IP address to this IP address. And then Hyper-V Virtual Switch tags it with the virtual subnet ID, and the network virtualization filter picks it up and then encapsulates it into what actually appears on the wire. So from provider address 1 to provider address 2, or the router or whatever it happens to be, and then from IP address 1 to IP address 2 and the virtual subnet ID. So then that gets sent on the wire, gets received at the other side, and the network virtualization filter unpacks that. Question? So the question is, what if you're trying to get to something on a physical network? And that's a good question, because this doesn't really work, does it? So there's a role called the Hyper-V Network. I think it's called the Hyper-V Network Virtualization Gateway. At the moment, you configure it up with PowerShell, and basically that does that. Because the situation would be, I'm trying to get to it. I'm trying to get to these virtual machines from my customer network, for instance. And so you've got this Hyper-V Network Virtualization Gateway, which does the translation for you. So there is, we have thought of that too. Well, oh no, I knew we forgot something. That is allowed for, and we're also working with hardware vendors, as I understand it, to bring physical devices that will do that network virtualization role as well. And basically, what happens is the traffic gets unwound through a reverse process and sent up to 10.0.0.7. So, a bit complicated. Let's have a look at what it looks like in the UI. So, Virtual Machine Manager. I said I had to manage it all. You have to manage it through Virtual Machine Manager. So what I've got here is I've got a couple of hosts, 4 and 5. They're not clustered. They're just sitting standalone. I'm running green VM1 and green and blue VM1 on host 4, and I'm running green VM2 and blue VM2 on host 5. what I've got here is a couple of VM networks defined. And so what you'll see here is I've got a blue VM network and I've got two different subnets in there. So pool 1 and pool 2. And so you can see they are different IP ranges. And also I've got a green VM network, which is just a single pool. And you can see it's got the same address range as blue pool 1. And I've also got my physical management network. So those are our different virtual networks and the virtual subnets associated with them. And then when I look at a particular VM, say blue VM1, and look at the properties, in Virtual Machine Manager, in our network adapter, you can see it's actually connected to a VM network, blue VM network, blue VM subnet 1. So it's actually connected to those virtual networks for us. And I'll show you blue VM 2 as well, because blue VM 2 is actually sitting on subnet 2 as well, just to prove that it's that it does work and the routing actually works. I had to prove it to myself to believe it. So there's blue VM subnet 2. So I've got two blue VMs on different hosts on different virtual subnets, and so so if we go and look at our hosts, blue VM1 192.168.1.2. That's its IP address. We can, if we've got enough. So the gateway is, so the question is what is the gateway? So it's here's 192.168.1.1. The gateway is the magic, okay? Just, Don't ask a difficult question. The gateway is the magic. So Virtual Machine Manager, when you define your address pool, you basically say, I want to use this address pool. It reserves .1 for the gateway, and the network virtualization layer takes care of the routing bit of that. So when traffic goes to 1.1, the network virtualization layer picks up and routes it with magic. And so there we've got 192.168.1.2 blue web server running on vhost 04, and same with green VM1, also 192.168.1.2, so running on the same network. There's no VLAN configured, it's just network vert, and 192.168.1.2. Do you like my ASPX skills? Me either. And just to I guess prove the point, here is blue VM2, which is trigger happy. Blue VM2, 192.168.2.2. So on the different virtual subnet, and you'll see the IP address of the gateway 2.1 there, which is the network virtualization layer, but we can still talk to 192.168.1.2 and not have a problem with that at all. So that's kind of how it all looks inside the combo of Virtual Machine Manager and the guests themselves. The guests don't, there's no configuration required at the guest. All the configuration is done here. We've just got our VMs and they're just attached to our virtual networks, and by virtue of that process they get allocated fixed IP addresses as they go through. We can support DHCP as well, but the IP addresses are allocated here, and away we go. So it's it just kind of works, and it is kind of magic as well. The question that I asked actually, and I don't know if you guys had thought of this, but what if you do a migration of a VM? So if you do a migration of a VM in Virtual Machine Manager, it'll do the network virtualization config for you. If you do a migration of a VM, say outside of VM, like using the Hyper-V tools or the failover cluster manager, and do a migration of a VM, what happens then? Does the network virtualization configuration follow? The answer is yeah, it does, but it can take a little bit longer to follow because VMM has to pick up that the virtual machine has been moved out of band of VMM itself. If it's doing the move, it'll manage the move of the IP address and locations and all that, but otherwise it has to pick up the change, and so that can take a little bit longer. What happens if Virtual Machine Manager is down? That's not a great situation because that, funny enough, because that demand paging of that lookup of MAC addresses and that kind of stuff won't be present. So it's not a great situation, which is why we put a whole bunch of stuff in Virtual Machine Manager 2012 around high availability and all that sort of stuff. So yeah, if you are using network virtualization, you want to make sure that VMM is made highly available as well. Yeah, it wasn't just something we did to make analysts happy, although I'm sure it does as well. So that was network virtualization very, very quickly. It's, it has a bunch of benefits, around, not just customer stuff, but, if you want to take stuff and run it in the cloud, it's fantastic for that as well. We also have a couple of other things in there. PVLAN support. So, this was actually, I think, the number one ask from hosters was we want to support PVLANs. So, the scenario is, hey, we just want VMs to be able to talk out on the internet and talk to each other, but not talk to other customers and stuff. So PVLAN lets us do that. And I talked about Developer Guard yesterday in the overview session. For those of you who weren't there, I call it Developer Guard, but it's actually called DHCP Guard, and it's basically the ability to stop DHCP traffic coming out from a particular VM. And I call it Developer Guard because it's that scenario. You give a developer a VM, they run up a DHCP server, and away you go. They've ruined your network for you. So someone did tweet, what other features have you got to stop developers doing all the other stuff that they do? So nothing really. Hit them on the head. Predictability. So moving on. So quality of service. So quality of service built into the platform inside Windows Server 2012, and so this is around providing predictable performance for multi-tenant or indeed single-tenant environments as well. This has benefits in single-tenant environments. So quality of service allows us to set maximum and minimum bandwidths on VM traffic. And so we can ensure that each workload gets their fair share of bandwidth, or a dedicated share of bandwidth. If you're billing on, hey, if you're charging on, we need this thing to have dedicated bandwidth, or you've got a VM that particularly requires dedicated bandwidth. Hyper-V quality of service allows us to do that. And so again, let's take a quick look at that. So. Back to these machines here. I've got two machines here. What I'm going to do is just run up a process that generates a whole bunch of traffic. I'm monitoring at the host side the traffic coming out of one of these guys. So I'll start up the receive process, and I'll start up the send process. And what we should see very quickly is a bunch of network traffic start thrashing between those two machines. And so what we can do is, there we go, set network adapter, VM name, maximum bandwidth, and hit enter. And what we should see when we go back here is that bandwidth's actually being throttled down by Hyper-V quality of service. So, and don't panic, this one isn't a PowerShell only feature. So, I can come into Hyper-V Manager and actually manage it from here. So it's set on a specific network adapter. So I can just turn bandwidth management off and go OK. And we should see a whole bunch of network traffic spiking up again. So really easy to manage. It's it's built into the UI, but it's also built through PowerShell as well. So you can automate it and do that kind of stuff. And so basically you can set you can set a bandwidth. That was setting a bandwidth maximum. Let's just quickly have a look at some of those other settings. Bandwidth management. So I can also set a minimum bandwidth. So basically a reserve. Pretty much, or that maximum, so I can cap it up if I want to as well. So, like I say, it's on a per virtual network adapter basis. So if you've got, so one example would be, hey, I've got a a network proxy that I want to limit the network bandwidth that it's using to get out to the internet. So I'm charging, maybe I'm charging customers on a per bandwidth basis or that kind of thing. You could, define it on that proxy, have its bandwidth connection controlled question. Ask the question again. How would you? That's a good question. So the question is, how would you resolve overcommitting minimum bandwidth? So I committed, I've got I've got a 1 gig network, and I've said the minimum bandwidth for everyone is, 10 gig or something. Yeah. I'm not sure what the answer to that is, to be honest. Is that? It won't be a quality of service. Yeah. Not quality of service. Yeah. I'm not sure the answer to that. What's that? No, I'll tell you what's happened. I run this thing called Flux. I don't know if you've heard of Flux. It is getting late. That means the sun's setting. There you go. So look it up on the internet. It's great. It's Flux. It's really good for working at night on LCD screens. It dims it down and does stuff. Yes, but it does make your screen go yellow, and it's not great when you're presenting. Yeah. Yeah, then it just goes dark. Yeah. I talked before about that network teaming scenario. Two 10 gig NICs teamed and running your converged, basically converged fabric across those 10 gig NICs. And I said, we'd talk about something that would help with how you deal with different traffic classes going across that. And that's where data center bridging comes in. So data center bridging is actually an operating system feature as well. And what that allows us to, data center bridging is an IEEE standard around managing traffic on converged networks. And what it lets us do is set up to 8 different classes of traffic and have those different classes have different priorities and different minimum bandwidths and reserved bandwidths and those kinds of things. And so it's built into the stack. And so one of the things you can do is, you could say I've got, a minimum of a gig. I've got a gig reserved for iSCSI. I've got a gig reserved for live migration. I've got a gig reserved for management, and then I've got the rest of my traffic available for guests. And so data center bridging allows us to do that. And this is something that's built into the operating system. And so basically, this is again a PowerShell only feature, but it leverages and it does require hardware that supports the data center bridging protocols. But there is a bit of hardware out there that does that, but it is built into the platform as well. So if you want to leverage data center bridging, then you can. It's a great little feature for that traffic classification as well. Scale. So how do we scale better with virtual networking? So how many of you went to Ben's 400 level session? It was pretty awesome. I love this. I learned so much in that session. And Ben talked about single root I/O virtualization, so I won't talk a lot about it. Needless to say, it's around mapping physical network adapters running that support the SR-IOV standard, them exposing virtual interfaces into your VMs, and basically those virtual interfaces, talking those VMs talking directly to the network card as opposed to going through the Hyper-V switch. So that's what that's about. It's great for scalability, and there's one scenario where it's kind of a pain in the neck, but other than that, it's pretty great. So. It basically bypasses the virtual switch altogether. The virtual machine has pretty much got direct access to the physical hardware. Like I say, I won't talk a lot about that. And we can do, it supports live migration, all that stuff. Ben showed that stuff as well. One of the other things is there's this thing called virtual machine queue. We actually introduced it in Hyper-V in 2008 R2. Virtual machine queue is another offload technology. It's slightly different than SR-IOV, and it doesn't bypass the Hyper-V virtual switch. But what we had in 2008 R2 was we had a bit of a performance bottleneck in that at the root partition with this with the offload, it was basically locked to CPU 0. So if CPU 0 got thrashed, then we couldn't necessarily scale very well in the virtual machine queue base. So dynamic virtual machine queue basically lets us figure out what the right number of processes to use in the root partition or the parent partition to be able to manage that traffic. So even if CPU 0 is getting hammered, we'll still be able to spread the load across other CPUs. And so this is just around scaling better, basically, in the VMQ offload stuff. So always turn VMQ on. So next, let's talk about extensibility. So what we've done with Hyper-V is we've added an extension framework into the virtual switch. And there's a few key things in this that we designed for. The first one is that the Hyper-V virtual switch should be extensible, not replaceable. So there's a couple of reasons for that. One is, and like I said yesterday, I don't want to talk about the competition very much, but I will here, but not to diss them or anything, but just to say what VMware have done with their virtual switch is it's a replaceable. You have to replace the virtual switch, which means that if you're going to write a replacement for it, you've got to basically rewrite the entire logic for their virtual switch. And that's kind of hard to do. And you can see that it's hard to do because the only people who have done it are Cisco and maybe IBM, I think. So it is kind of hard to do. So we'd like to make it easy to do that, and so we'd rather add an extension framework rather than you guys having, rather than OEMs having to write complete full replacements for our virtual switch. We want the switch to be able to deal with all network traffic, so even traffic's going between VMs, we want the virtual switch the extensions to be able to handle that. We want to be able to ensure that things like live migration and offload and all that kind of stuff continue working even though we're using virtual switch extensions. We want to have an open public API for this so that anyone can build them, and it's great. We do have logo certification around this for making sure that extensions aren't going to ruin your system, and we have got a bunch of tracing through the virtual switch so you can actually figure out what's going on as well. So this is it. Customers who want to do something different in the virtual switch, be it firewalling, be it replacing the switching logic, those kinds of things. So basically what we've got with the virtual switch is we've got two paths through the switch, ingress and outgress. So every bit of traffic going through the virtual switch goes in and out through the extensions. So if VM on the right is talking to the VM on the left, then it goes right through that virtual switch extension stack, and which means that every one of those extensions can do something to the traffic on the way. Oh look, nice little animation like that. Yeah, pretty cool. And there's also a control path in here as well. So we can do things like, hey, how many ports have I got attached to this virtual switch? And so we can query down into the virtual switch and get information about its capabilities out of it as well. And the other thing we can do is those extensions can even do things like, hey, I want to attach a new virtual machine. A virtual machine comes along and says, hey, I want to attach to the virtual switch. They can go down the extensions and say, no, not going to happen, and it can actually block that VM from even attaching to the virtual switch. And so it actually allows us to do that as well. So there are basically four types of extension. There's a capture extension, and a capture extension is basically a read-only extension. It's basically used for inspecting traffic, for doing maybe analysis, maybe sniffing, I don't know, whatever. But it is a read-only extension. It's there just to look at traffic going through the virtual switch. And you'll notice it sits at the top of the stack, and that means that it can look at traffic as it comes out of a VM and as it returns back again. So because these other extensions below it could end up modifying traffic on the way. So you will see at the capture extension, you will see the traffic as it has left the VM rather than as it's been modified by some other extension. And when it returns up, you will see it after all the modifications have been done. You will see it at the top as well. So that's why the capture extension sort of sits logically at the top. Oops. I thought there was something else in there. I might have put that slide in the wrong order. We can support live migration, so each of these virtual switch extensions actually allow us to notify them of a live migration and send a message down saying, is there any configuration data that you need to save as part of this live migration? And that virtual switch can say, yep, here's my data, fire it back up to the virtual machine and transfer it across so that the virtual switch extension on the other, on the destination host can actually pick up that configuration as part of the live migration as well. So support, again, we don't want to build stuff where you have to turn live migration off or whatever. So next extension, those two slides, sorry, got a bit mixed up. The next type of extension, Windows filtering platform extension. This is in here. This is basically an extension that lets you modify traffic, do all sorts of stuff, written into the Windows filtering platform framework. So we've got a bunch of people who know how to do that, so we can leverage that. And so basically, we can have multiple of these guys sitting in here, and this is just around modifying traffic. It might be firewalling, it might be inspection, those kinds of things. It might even be injecting traffic in. Those kinds of things. It is able to modify traffic. Filter extension is exactly the same as a WFP extension, except it's an Indus extension rather than WFP. So it basically does exactly the same thing. So it can modify traffic. And the last sort of extension is a forwarding extension. And so what the forwarding extension does is basically completely replace the forwarding logic of the virtual switch. So normally the virtual switch itself would deal with, hey, this packet goes over there, this packet goes over there. This replaces the whole lot completely, and this is where things like the Cisco Nexus 1000V would sit. So where you're replacing it with some external switching and routing logic, that's where it sits. And so it sits right at the bottom of that stack. And at that point, if you're using a forwarding extension, you can only use one, so it completely replaces that Hyper-V stuff. So Hyper-V, the Hyper-V virtual switch, forwarding logic and stuff basically gets turned off at that point. A bit of duplication. Back there. So we talked about. I talked yesterday about the different partners. Inmon doing an S-Flow virtual switch, Five9 doing a virtual firewall. The Cisco Nexus 1000V's out there, they're going to release, and the NEC OpenFlow virtual switch they're out there as well. And we might as well quickly take a look at that. We did see this yesterday, but our virtual switch extensions are pretty much just loaded into our virtual switch here. We've got an extensions tab, and so we can see our different types of extensions and how they're loaded. So you can see the Indus Capture, which is our port filter one. That's actually a built-in one. That ships out of the box. It's turned off by default, and there's a Windows filtering platform one that's also out of the box. The S-Flow one is the one I've got installed, and that's a capture virtual extension, so that's the read-only style. We've also got, when you install the network virtualization, or enable network virtualization with VMM, it actually installs this DHCP server switch extension as well. And this allows DHCP traffic to go across the network virtualization stack as well. And so what we've got inside Virtual Machine Manager 2012 SP1 is the ability to centrally manage these guys. So we can define things like a logical switch and then have the extensions built in and then push that configuration out, so the Virtual Machine Manager takes care of deploying the extensions and having them enabled and that kind of thing. So you can actually manage the Hyper-V virtual switch configuration centrally through Virtual Machine Manager as well. And that's all, of course, also managed by PowerShell. Get VM switch extension, BBC. And so you can see, same thing. You can see all those virtual switch extensions that I've got enabled there, and I can turn those off, turn them on through PowerShell, or I can turn them on through the UI, or I can, again, do it all through Virtual Machine Manager as well. So you've got different options for interacting with those virtual switch extensions. I guess I haven't got the UI up for the S-Flow. In fact, I'll bring that up quickly. So, and have a drink. Any questions on the virtual switch? Whoops, got that wrong. Yeah, so here's our S-Flow, Inmon S-Flow dashboard. This is using data that's being captured, being sampled every 30 seconds or so of traffic going through the Hyper-V virtual switch on 3 hosts. So we can see I've got 3 different hosts here, and so you can see, there's my green VM and there's my blue VM that we were talking about before, and so we can see the various bits of traffic, and we got a whole bunch of different pretty pictures and things around various bits of traffic. that's going through this. So, nice. So this is just capturing data, so using a capture filter and firing it back to an S-flow collector and mapping, and we're mapping that stuff in. So, and that's just a simple Hyper-V network extension. I don't know why it does this, but we're going to change again. Right, so let's talk about manageability. So, one of the things is around how do we manage this at large scale. So, and how do we do some other stuff. So, one of the things is Hyper-V metering. So, I talked a little bit about this before. Metering is about how do we measure what a particular VM is doing, and how do we track down its network usage, and how do we do that? How do we charge back on that sort of stuff? And so, metering is built into Hyper-V. Networking is part of that, and we can build charge back on that. So. Metering is implemented as a port access control list. Same thing as we talked about before, that the metering data and usage data is preserved across a live migration, so I can set an access control list on a virtual machine and have that data preserved as it moves around your data center environment. You don't have to worry about reconfiguring stuff when it moves. That configuration and that usage data moves with it. So again, let's have a quick look. And metering again is another one of those PowerShell only features. And I've got it all typed in because I'm lazy and because my typing's terrible. That's because I'm on the wrong host. There. So what I've got is I've actually got VM metering enabled on this BPC VM MSP1 VM. And so what I can do is if I want to see the usage data for that VM, I can just do measure VM name, and it'll give me basically a little thing here. So it shows me average CPU in megahertz, average RAM in meg, and maximum RAM and minimum RAM as well. So you can see if you're using dynamic memory, you can see where it's got to, and its low point, its high point. The total disk space it's using in meg, and you can also see your network inbound and network outbound traffic there as well. So I can also do this and set it into a variable, and I can actually get a particular. I can break down that traffic a bit further, so I can actually run this network metered traffic report object and action and grab the traffic broken down into outbound and inbound traffic, and with those port ACLs you could actually be quite granular about turning on monitoring. Metering of particular traffic if you wanted to. I want to see, and Ben gave me the example before of his home network, and it's quite sad and nerdy, but Ben gave me the example before. He actually used it he turned on metering for every individual IP address in his home network, so he could figure out which machines were using the most traffic against his file server, because he thought his file server was delivering a lot of traffic. So that's the kind of thing you can use it for. You can actually be quite nerdy and sad. But don't tell Ben I told you that. Ben, he's not here, eh? No. Good. Hey, look, and we're almost done, and it's almost time to go to the cloud.
Did he tell you if he was using all of them?
He didn't actually. I think it was his daughter watching movies, I think. So the other thing is, PowerShell, the virtual switch and all that stuff is all configurable through PowerShell. In fact, it's more configurable through PowerShell, as you will have seen. We've got some unified tracing built in. We've got port mirroring built in, which I guess is one of the other big asks that I've often had from customers. Hey, I want to see what traffic's going on in this VM. How do I do that? In 2008 R2, that's actually really hard. In fact, impossible. So port mirroring is added in as well. So, look, we've talked pretty quickly through a bunch of stuff, mostly looking at the extensibility and the security stuff, the network virtualization stuff. We've built a whole bunch of stuff that we think is pretty powerful and pretty usable. And with the addition of VMM 2012 SP1 to provide that sort of central configuration point, that's going to add a whole lot of extra value as well. So, thank you very much for staying late. I know that it's right before the party, and I do have to ask you to do your evals, please. And I do also have to give away this beautiful Acer Ultra book. So I'll ask a question. What's the difference between a WFP filter and a normal filter? That's pretty much it. I can't give it to you, unfortunately, Martin. Government. Everyone's either government or a speaker who answers these questions. What's another question? I should have come prepared with more than one. Why does the capture filter sit at the top of the stack?
Capture ingress and egress so that you see the unmodified traffic.
Good job. Cool. And thank you. Hey, thank you very much. There's a few other sessions tomorrow on a bunch of other. Ben's running a couple more sessions on replica and migration, so go and see those. There's a bunch of other Windows Server sessions as well. Thank you very much for coming to TechEd. It's been great. Thank you.